it's really important that whatever you're working on and whatever the engineers are working on, they're having fun, they're enjoying it. And that doesn't mean that you're fooling around horseplaying all the time, but it means that you feel a real value in the job, that you make a difference, and you enjoy doing that.
Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. I am here today with Carsten Thomsen, and it's actually your birthday, right?
That's right.
There you go. Well, congratulations. Happy birthday, and thank you for joining us on your birthday.
In an hour and 25 minutes, I'll be 76.
Wow. There you go. So I guess perhaps the best place to start is just, can you tell us about your work at NI and what you did at NI, and then maybe we can go from there and branch into some interesting stories.
Yeah, NI was actually sort of a culmination of some of my crazy dreams. I grew up in the US. Well, actually born in Denmark, lived here for 9 years, and my parents emigrated and got my education there, and never turned into an engineer. I'm a math physics major, so I'm sort of moonlighting as an engineer all my life, faking it until you make it. And I work for a Danish instrumentation company, Brüel Kjær, which is a leader in sound and vibration instrumentation from 1973 to 1993. And I've been always fascinated by computers, even from way back in college when we had Hollerith cards, those holy cards, Fortran Ford and that type of stuff, job control cards. And as I started working in the instrumentation world, what really fascinated me about it is it's incredibly interdisciplinary. It just covers the entire spectrum of technology, also including human factors, because you have user interfaces, and software development is an extremely human factor oriented thing. So is hardware development, transducers, A to D converters, and all that good stuff. Well, anyway, in 1993, after 20 years of Brüel Kjær, I got an offer from a little scrappy company in Austin, Texas. And I didn't want to move to the US. My family and I were all settled there, but after some long dialogues and so on, I gave in when Ron Wolf brought me a bag full of chocolate chip cookies from Blue Mountain Chocolate Chip Cookies, I think it was called, trying to bribe me to take the job. And it was a great ride at NI. I was there for 7 years. I'd promised to be there only for 3 years, but I had so much fun. And that sort of sums up my professional experience, that at the top of the list, it's really important that whatever you're working on and whatever the engineers are working on, they're having fun, they're enjoying it. And that doesn't mean that you're fooling around horseplaying all the time, but it means that you feel a real value in the job, that you make a difference, and you enjoy doing that. I always had an aversion to hiring people who wanted the money, and sort of filtered them away because they weren't focused on the customer, the technology, the innovation, and those type of stuff. So I joined NI in 1993 and was VP of engineering there for a number of years. And I finally told Dr. T that I was bailing out, moving back to Denmark, which I did in year 2000. And then Tim Denny, who was VP of marketing, took over. So that's sort of the highlights there. It doesn't get into the nitty gritty of what we actually do, the way I think and the way I manage and so on.
Yeah,
But
I
we'll dig
really
into that.
like that idea of work should be fun. I feel like doing what we do, writing LabVIEW code and stuff, there's like this moment, like when you type something into the computer and you just get the light flashes and you're like, oh, it's like this like moment of joy. And I feel like sometimes people lose that over the years.
Yeah.
Sometimes I think, like you said, it's people who are just focused on the money, but also sometimes I feel like working for certain companies, sometimes the processes and things get in the way of that joy. And I'm a big believer in, like, if you're not having fun at work, then something should change, whether that's changing jobs or whether that's changing where you work, or
Right.
changing your outlook or something, because like life is too short to work away at a job that you don't really enjoy.
Right. And the trends in society and technology also is there are more and more standards and more processes. They're just heaped up on our desks that we sometimes don't have time to do the work. And I like Dr. T. He said, at NI, we only have the rules that the government requires us to have. And then we trust our employees to use common sense and normal ethics.
Yeah, I
And
think that's
that's being thrown out the window nowadays. They can't trust you to do anything. You have to prove you're a good person.
I've definitely worked at companies where, yeah, there's a variety of reasons for that. I think one of them is like fear of litigation. Oh, so, we might get sued, so we got to be careful. We got to control everybody. Um, there's that. There's a variety of other things. I think part of it too is, like, as you get a larger and larger company, as a small company, you know everybody you're hiring. You can hire people you trust. As you get larger, that gets a lot harder. Um, there are a variety of reasons for that, but yeah, I'm a big fan of just enough process to prevent chaos and to
Right.
things from going off the rails. There's a saying called something like "Don't scar at the first cut," which I think is a really interesting saying. I think it's Jason Fried or something. But basically,
Okay.
his thing is like, if you have an incident, you don't immediately need to create this blanket policy of, oh my God, we have to control everything so this never happens again, right? You deal with the incident, and then you tell everybody, you say, hey, look, hey, if this becomes a problem, we're going to have to come up with a policy. But you don't need a policy for every little thing that goes wrong. I think
Right. And
that's
it's the same thing with legislation. Something goes wrong, somebody swindles and cheats and tax, and then they add a new layer of legislation and bureaucracy.
yeah. When in reality, they just need to like go smack that person and
Right. And
well, the other thing I too think that is good for some of that stuff, and I don't see people doing it enough, is this idea of in the agile world they call it retrospectives, but basically just at the end of every project to sit down and look at it and say, well, what went well, what didn't, and if you
right.
find that there's some process that you're doing that's just not adding value, why are you doing it? If you're having weekly meetings and at the end of the project you're like, yeah, we didn't really need those. Well, the next
Yeah.
project don't do them.
Right. Yeah. I remember when I joined I was actually in the US interviewing for a job. I mean, the company I was working for was in severe financial difficulty, so virtually everybody got laid off, including me. And they wanted me to come over and talk with them. And they hired me for a week consultancy, and I talked with about 40 people at NI. And of course, the agenda was hiring me. And I saw this extremely innovative, fast-moving company where the quality was really very marginal, to put it diplomatically. I remember DAQ-mx, or NI-DAQ as it was called in the old days. We were doing new releases every 2 or 3 weeks because it was just so bug-filled. So one of my main agendas when I came over there was to try to fix the bugs, and we had a lot of processes where I worked in Denmark and moving, not plotting, but carefully thinking about everything we're doing. And that takes longer, but you have a really good product at the end. And I thought that if we applied those processes at NI, I would destroy the culture. So the only thing I did after walking around talking with the folks in the company for the first 2 months that I was there is just basically saying I'd like to have a formal bug tracking system. They didn't have that.
Oh yeah, just bring
And
attention to it.
that got a lot of opposition. And I remember I was talking with Jeff Kay about it, and he says, I know when LabVIEW is ready to ship. Normally, Jeff is a very nice, affable person, but we almost got into a minor shouting match about it. And I said, that's the only thing I'm requiring. I'm not requiring any processes. I'm just requiring that you log the bugs, and I have somebody help you to log the bugs as a function of testing time, not calendar time, but testing time. And the theory is that that bug curve will increase exponentially during the first part of development, and then it'll flatten out as an S-curve once you asymptote something that resembles stability. Well, we implemented that. And I remember a couple of weeks or a couple of months later, Jeff Kay said, yeah, I wish we'd started doing the bug tracking before then, because you got visibility of what's going on. And when you have enough digital events in terms of considering each bug as a single bit event, when you get enough of those, it starts following the laws of statistics and shows very reproducible curves, which in this case is an asymptotic curve, an S-curve. So that worked. And I then let all the different engineering teams have their own processes that suited their culture. So we didn't top-down impose a engineering process. And that meant that they had ownership of quality. And then we had discussions about what are the release criteria. And I said, I'm not going to sit at the end of the table and dictate whether we release the product or not. That's up to you guys. You have the statistics, you know the product better than anybody else. And by pushing that decision down in the organization, we were able to dramatically increase the quality. I think we reduced the bugs by a factor of 10 in 2 years. And that had an interesting side effect, because normally at the sales conferences, every year they'd be griping about the quality level of the products. And I remember a couple of years after that, at the Summer NI week up at the Renaissance Hotel in Austin, Dr. Chi came over to me and he says, you know, I'm worried that we're not pushing engineering hard enough. And I said, why not? Well, the salespeople aren't complaining about the bugs this year.
That's pretty funny.
Yeah, and there's a lot of wisdom in that, because his philosophy is that when you're driving people to perform, he makes a parallel with pushing the throttle forward on an aircraft. And he says, I like to push the throttle forward just enough until the engine doesn't sound very good anymore. It sounds a little rough and so on. And then I pull back so it's running smoothly. And that's, you know, in aviation, that's the way you run your engines. You don't run them at full throttle, you'll destroy them. You run them at 70, 75, maybe 80% of full throttle, and that gives the best performance. He was a very smart guy.
Yeah, that kind of reminds me. I used to work in an R&D department, and basically one of the sayings we had was like, if you're not failing occasionally, you're not really doing true R&D. That like if you're
Right.
truly trying to push the limits,
Yep.
you don't know where the line is until you occasionally cross the line.
That's right.
Yeah, I mean, I think part of the key to that is doing that in a way that's not fatal and like, you know, you can recover. But yeah, if you don't know where that line is, you're always like hedging way below it.
Right. And of course, I think some companies like Facebook, they push things too far by, you know, just, you know, move fast, break things.
Yeah.
And I wouldn't want to fly in an airplane that was where the software was defined or by Facebook.
No, yeah, that would be bad.
Yeah.
Yeah, there is a difference between experimenting and just move fast and break stuff. Experimenting
Right.
at least implies more controlled, more thought out. You've thought about what the potential consequences are. You've tried to mitigate them. You're trying to do it in a way where if it does blow up, nobody's going to get hurt.
Yeah, you go off in a sandbox, build a rapid prototype,
Yep.
and
Yeah,
that's an important process.
although the prototype thing is always interesting because I'm sure you've run into this, but often somebody goes and builds a prototype and they just throw it together, and then someone in management looks at it and says, "Great, let's ship it." And you're like, "Wait, hold on."
Yeah, management comes, oh, you're done now.
Yeah, definitely that is a thing. So it's good to be clear that it's an experiment
Right.
and be prepared to throw it away and start over. Because honestly, that's one of the misconceptions, right? People think like, oh, the prototype, the value is in the prototype. The value is actually in the learning how to build the thing and learning that, hey, it actually has a market and people actually want it.
Right. I often did, after I left NI, I'm an amateur LabVIEW programmer, but I love sitting with the end user and getting them to help define what they want. And they hate me for it because I simply grab the LabVIEW and I build the front panel interactively as we're discussing things. We don't write it in words. And then they think I'm a pain in the posterior because it says, well, what units do you want here? And how many digits accuracy do you want? And what are the limits on the input data, the upper and lower limits and so on? And what are the side effects if you select this function? What other ones should be blanked out and so on? And I just keep going at them. And the interesting thing, in that process, it gives me a front panel and a user interface that they have seen on day one or day two. But there's a danger in that also because this type of prototyping, or whether you write a written requirement specification, by the time people get to page 97, they get tired. And they start leaving very quickly through the thing. And they say, yeah, it's okay. And then 2 years later or a year later, when you deliver the stuff, there was some uncertainness or fuzziness about something. And there's, oh, I wasn't aware of that. And in the interaction with the end user, you have to be very careful to make sure that you are harvesting their experience and their input in a high quality manner, and that you don't run into this getting tired phenomenon. It's a very dangerous thing.
Yeah, I've definitely noticed that. Another thing I've noticed too, though, is that sometimes what they want changes over time. So if you're doing a 2-year project and you do the
Right.
mock-up at the very beginning, 2 years later, they might be like, oh, well, everybody else in our industry is looking at this metric. Can we show this metric or that
Exactly.
graph?
And that's why you want to come back repeatedly to them. And I also sometimes I say, there are alternate ways of doing this. Do you want a lot of pop-up menus, or do you want it all on one large interface where you aren't switching between tab sheets or other types of things? And those are very fundamental decisions. And I've seen some really terrible software written in LabVIEW, among other things, where it's just nonstop pop-up windows all the time. Every function you click on, there's a pop-up associated with it. And I think for many things, I like the airline cockpit where you have a fairly high bandwidth in terms of the number of dials and controls that are displayed to you, and they're sitting in fixed places. So you always know where to look and you don't get lost in the interface. And same thing, I hate modern cars that have too much touchscreen stuff in them and not enough dedicated buttons in fixed positions,
Yeah.
because that becomes a safety issue.
Yeah. One trend I've seen is definitely organizing stuff based on the programmer's needs and not so much the end user's needs. As an example, I
Yeah.
worked on a system where it had like several different stations, but each station had a motor and each station had a set of limit switches. And so they had one tab for all the motors and one tab for all the limit switches and one tab for all the pumps. And it was very difficult to navigate. Whereas the operator looked at it as, I want to run this one particular station. I want to see all the controls for this station on one tab.
Right.
So
Yep.
just reorganizing things like that made it a lot easier. But it is interesting. There was some resistance from the operators because they were used to the old interface.
Yep.
So it's amazing what people can become used to.
I mean, people can become used to some really atrocious things,
Yeah.
and that's the way it is.
Yeah, well, it's kind of funny, I think there's like some Henry Ford quote or something like, if I'd asked people what they wanted, they would have said faster horses, right? Because they're so used to horses
Right.
and their mind's so set on, oh, well, I get around on a horse, and yes, I'd like to get there faster, but that means a faster horse, not that means a completely different way of getting there.
Right. You need better whip so you can whip the horse more.
Yeah, well, I think that's like focusing on the technology and not the goal.
That's right. But sometimes knowing the future of technology by looking in the crystal ball, you can see stuff down the road 5 or 10 years from now. And I think that's what NI saw. They saw the computers revolutionizing instrumentation with virtual instrumentation. And it was seeing that long-term thing before the industry in general recognized it that helped make some breakthrough innovation there.
Yeah, that's interesting. So what long-term trends do you see right now?
I'm probably a grouchy old man. I remember in the late 80s, the big fad was
AI.
artificial intelligence. And I remember I flew to Los Angeles and visited a couple of AI companies in the LA area. And we actually bought an AI package that cost 1 million Danish kroner. That's about 180,000 US dollars. That's a lot of money back then. To do some simulation of some low level hardware protocols to make sure that they were running beneath the operating system to make sure that they were 100% reliable. And we used AI to simulate that. And that was everybody was all hyped up about it, and then that died, and those companies don't even exist anymore. AI is, massive computers with massive memories that are trained on massive amounts of data where it is unknown what the quality of the input data is. So garbage in, garbage out, and which is why AI is asymptoting in terms of what it can do. And yes, you have complex reasoning models and so on, but it's basically based on pattern recognition. And pattern recognition is correlation, and the correlation is based on correlation to what the data that you're trained on, that what the consensus is in that field where you've been harvesting the data. So in America, you may get one type of correlation. In Japanese, you may get another because there's different values and different ways of doing things.
The interesting thing that I think about all this AI stuff is people talk about how it's going to be revolutionary, it's going to change everything. But in reality, AI is kind of a conservative force if you think about it. Because it's all like, especially the LLMs are all predicting the next most likely token. So how likely is it
Yeah,
to
right,
be brand new if it's
right,
always going to trend towards the mean?
right.
Yeah, I
And
think
the good writers sometimes stuff in an unexpected word. They take a classic phrase and then put a new word in there, which triggers an imagination and a provocation or a new idea.
yeah, that's the other thing that about the AI craze right now is like they seem to be solving for certain problems like basically getting rid of art and music and things like that. And I don't think that's what people actually want. I think people would rather they get sort of the drudgery of life and let them do more art and music, but maybe that's just me.
Right. But of course, there's an aspect, I think, of AI that is not discussed sufficiently. And that is if you look at NVIDIA's partnerships with various scientific modeling, finite element analysis, biological, chemical engineering, and so on, there are huge packages in that domain that embody thousands of man years of domain experience.
Mhm.
And by running these models on NVIDIA's hardware,
Mhm.
they're able to make more model runs that you normally would. And then they have APIs to that to be able to play these what if scenarios if we change this or that parameter. And those partnerships that NVIDIA has there are, I think, very, very valuable. And it's more than LLMs. I mean, they're mining carefully validated engineering models that use huge matrices of differential equations that have been thought about and tested for many years. And that's a value that I think is a much more long-term value because there you're mining existing packages that have proven themselves in the field.
Yeah. So there is a worry that I think that's a very good point, but there's a worry that I have, and I think we're seeing this in the LabVIEW world right now. So to tie this into LabVIEW a little bit, right now, one of the major problems in the LabVIEW world is that people are having trouble finding entry-level LabVIEW engineers coming out of college, okay? Because
Yep,
they're not
right.
exposed to it. And then I kind of had abandoned for a while the academic market, and they're coming back. But the thing I see with AI that's very similar to that is the sense that, okay, like there are this group of people that say AI is going to replace programmers, but really, at best, it replaces the entry-level programmers at the moment. So if you replace all those entry-level programming jobs, in 20 years, who's going to be left who can actually do any programming? Because nobody's going to come up through the ranks.
Yeah, and as you come up through the ranks, your, shall we say, wisdom, your experience
Mhm.
in terms of how to design systems for performance or for reliability or low latency or whatever, avoiding unnecessary complexity. Where is that repository of wisdom? I mean, it's in old farts like you who sort of have a good feel for how to do high-level architecture that works and will continue to work. And most of the stuff that I see, the automatic code generation, it's, write a program to play tic-tac-toe or to do this or that, or write a Python script to get some data and display it in a 3D graph. And, it all goes back to fundamental education, logical thinking, and I think everybody should be forced to do machine level programming on day one and understand how you program and move things between registers and how you swap registers and that type of stuff. Because we have such high levels of abstraction that the waste going on underneath the hood is so enormous, and the potential for high performance is actually much, much greater than typical systems perform at. And probably my pet peeve is that people talk about proving that a program is logically correct or consistent and so on. But a program is not software. It is a combination of hardware and software. And all software interacts with the real world. And computers get hot and they throttle. And you have crosstalk from in the cosmic rays and EMC getting into the system. All of these kind of subtle things that you don't normally think about, but us who've grown up in the interdisciplinary world know that that happens. I have a good friend, she's scared of computers because she says every time I touch them, they crash. And this friend of mine, she also says, "Oh, don't open more windows. The computer will get confused. It'll crash." And at some level, there is a lot of truth in what she is saying, because when a computer is multitasking, it is constantly pulling things in and out of cache memory and redeploying its resources to do something else. It's sort of, the analogy is my boss comes into me and says, "Carsten, don't work on that anymore." And then he just shoves all the papers off my desk and I have to work on something else. And then I have to pick it up off the floor and get it back in order and so on to work on it. A context shift at the machine level is an extremely complex and compute intensive and potentially dangerous thing.
Yeah, that's interesting.
I mean, I think a typical interrupt in Windows at the machine level eats somewhere between 5 and 10,000 machine level instructions.
Wow. Yeah, that's a lot of moving stuff around.
Yeah, I mean, it's scary because how many levels of caches do you have in a computer also? You got the on-chip registers, you got an L1, L2 cache, you got disk caches on the SSD controller and so on. And all of that data is constantly being managed behind the scenes to supposedly optimize performance. But every time you flush a cache and so on, you introduce indeterminacy and risks of all kinds of crazy things going on. It does work very reliably most of the time,
Yeah.
but it's messy.
Well, it also does present a security risk. That whole Spectre meltdown thing that people were going on about a while ago was all related to that, and that, like, not only was it switching context, but in order to be more efficient, it was trying to predict ahead. And so when you switched context, you could see where the other one was going, and it
Right, the speculative execution, and then you suddenly got to throw it in reverse. And when you're doing that, you're vulnerable for intrusions.
Yeah, that's really crazy to think about how all those low level, and it comes a long way from, like, I remember taking a basics of computer architecture class way back when, and it was just simple, like, registers and moving things around and all
Right.
that. And it didn't even have all the context switching. So,
No, that's right.
but
But I
oh,
think an important thing I remember back in the 93 or 94 in NI DAQ, we were discussing where the salespeople were complaining that the single point IO was very slow. about 1 millisecond to get a single point of data. If you get an array of data, it was fast. And I had the engineers look at it, and I said, first thing, I'll give you the rest of the afternoon to write a machine level program to make a single point I/O on the raw hardware, and then tell me how long that takes. And it takes under 1 microsecond. So everything else we were adding with, and at that time, NI-DAQ had error checking in every level of the software, and that was extremely expensive. And there was 1,000 times difference of what the hardware could do and what the software on top of it was actually doing. And I think it's important to understand what goes on in the basement of the hardware. And they don't teach that enough in school today.
So I have a question for you because I tend to have a slightly different perspective on this.
Good.
Yeah, well, in general, so there is a quote, something like premature optimization is the root of all evil or something like that, right? But I feel like there's two schools of thought. One is always write the most optimized thing possible for optimized for performance.
Mm-hmm.
And I've always thought the performance is usually good enough. Focus on writing it so that it's easier for people to understand. And my question to you is, how do you balance those two things? And I think part of it obviously depends on your application.
Depends on the application. And what you're saying is a classic example of Dr. C's genius of the end. The only reason that I wanted that benchmark is just to know how fast things could go. I didn't say that we wanted to run that fast.
Yeah.
But it gives a way of finding a happy medium, a happy compromise that is good enough.
Yep.
But if you look at some of the stuff that we're doing in the high frequency gigahertz A to D converters that NI has today, every bit of performance counts. For MIO cards and so on, it's not an issue anymore, and the computers are running faster and faster, and it's not an issue. So you have to very carefully case out what's important.
Yeah. Well, to your specific example too, by seeing how fast the hardware can read, you're also eliminating the fact that it is something in the hardware that's just causing it to go slow.
Right.
Right. Which probably was not
it gives you the outer limits of what's possible.
Mm-hmm. Yeah. No, the optimization one is interesting. I read something somewhere where basically optimization some people think, oh, well, if you optimize your code, it makes it easier to read, but it almost always makes it harder to read, because usually when you're optimizing, you're picking corner cases. And so you add up all these like corner cases and conditional logic that you've got to keep in your head.
Yeah.
Yeah.
No, I mean, optimization should be localized. It shouldn't be spread out all over the place.
Yeah, that's the other thing too. Like you run, one of the things I've heard Darren say about the not optimizing too soon is, you think, oh, this is the problem over here, and you actually run the profile and you realize, no, the problem's actually way over here. And usually it's like, it's that whole theory of constraints thing, like that whatever the slowest thing is, that's your bottleneck. And if you fix anything else on either side of it, it doesn't really matter as much.
Precisely.
So trying to
focus.
It's
the old story about you're not supposed to use property nodes and references because they're inefficient.
Yeah.
But if they're used for doing a front panel thing, which is just a one-time affair, you click the mouse and then you turn off the visibility of 5 other controls. It doesn't matter that it's done by a property nodes because it's not a repeated thing. It's not running in a loop.
Yeah.
So
yeah, that's one of the mistakes people make. They put stuff in loops and they either make the loop really tight or they open and close the file inside every loop or something. Yeah.
Yeah, some stupid things. But it's also useful for people to burn their fingers on those type of things. So that's the best way of learning. Like what Taylor sent me, she says, "Where did you really screw up, and what did you learn from it?"
Yeah, that is an interesting question. Yeah, so let's ask that question. Can you think of an experiment you tried and where you burnt your fingers?
Yeah, I wrote down actually 4 different answers to that. First one was when I worked as a mail carrier in Battle Creek, Michigan, a summer substitute carrying mail. And I was under the impression that when you worked, you wanted to be efficient and work hard and be done quickly. And I didn't understand who my stakeholders were. I was basically ruining the mail routes for the for the salaried carriers, they were used to having full 5 hours out in the field. And they kept telling me, well, stop at this coffee shop here and there and so on. And I was always coming in an hour and a half, 2 hours early. And the bosses loved me and all the other guys hated me. So that's not understanding who your stakeholders are.
Yeah,
So that was a mistake. They hated me.
yeah.
But probably a more relevant example is I read in 1980 in the Electronic Engineering Times, I think it was called, about Hewlett-Packard working on a project called Project Redwood. I haven't been able to find the references to it, but they were talking about virtual instrumentation where that was just going to knock the socks off the instruments, doing all the instrumentation based on faster and faster A to D converters and faster DSP processors. And I was an early mover internally at Brüel Kjær on that, and did a lot of research into it, and finally persuaded management that we were to embark on a major virtual instrumentation family of products based on the VXI form factor. And we started that project in 1985 and released products in 1991 at AutoTestCon. And me not being a software engineer, I did go out and hire some of the best software engineers in Denmark, and they were very good. And I said, well, I want to be able to, inside a VXI chassis, to take a stream of data coming from an A to D converter and then connect it to 2 or 3 different processes while the system is running. Because you can do that with a BNC cable and T connectors on the front panel there. You can share data streams, and it doesn't crash the system if you pull off one of the connectors and move it somewhere else. And I wanted to be able to do that digitally.
Mm-hmm.
And they looked at me and they said, Carsten, you know what you're asking for? That's very hard to do. And because you're talking about real time streams of data, and there's all kinds of coherency and protected regions of code and bus bandwidth and on they went about it. And then also I wanted to be able to network workstations of VXI chassis sitting on Ethernet to remote workstations. We used Sun workstations at that time. And I wanted to be able to have the front panel of the instrument running on a VXI chassis and then exposed on a Sun workstation 50 meters down the hallway. And they looked at me and says, Carsten, there's really no state-of-the-art technology to do that in 1987 or so. So I said, well, Sun and all those big guys, haven't they figured that out yet? Nah. So my guys had invented a remote object invocation protocol for doing that type of stuff over the web. And we actually also developed, based on NCR, European Research Center, an object-oriented operating system that made the dynamic switching of processes and the dynamic sharing of data in a disciplined way, creating data streams and shutting them down while the system that was running. And when we showed that at AutoTestCon in 1991, there was a couple of guys from this Go Get 'em company down in Austin, Texas that came over. One of them was Dr. C and the other was Ron Wolf. And we stood there, demoed this stuff. And normally they're quite talkative, both of them. And they just stood there quietly looking at this stuff. And they saw it actually running, it was actually working, and we were dynamically creating a new instance of a virtual instrument, dynamically connecting a data stream to that, where it was sharing a data stream already coming off an A to D converter from something else. And they looked at it and, is this real? Does this really work? Is this a tested shipping product? Yes, it was. There's over 1.5 million lines of source code in it. And it was very carefully put together and in successive sub-integrations. And I remember the final system integration, it took 2 weeks, and we were running a system that was actually without any major crashes. But that's the plodding, careful approach that gives that. Well, anyway, Ron Wolf went and whispered in the ears of Fred Bodie, who edited the VXI Bus newsletter. He said, it's too good to be true. And that's what Fred Bodie, he wrote a very positive article about it. He says, but is this really real? Some obscure company in Denmark doing this type of crazy stuff. It was real. But it was an interesting process. But at the same time, the company I was at, they had 5 major projects of the same scale running in parallel. We were 60 people on this project here as a big team. And we were working on large ultrasonic scanners and machine monitoring, each of them running from 40 to 60 people. And that almost ran the company into the ground, into bankruptcy. So everything got put up for sale, and they chopped the company into pieces and sold off the pieces. And, many of the stuff got stopped, including the virtual instrumentation project.
So what is the lesson that you take away from that? Because I'm listening to it and my thought process goes along the lines of something like, if your product's too new or too outside the norm, you have to kind of prepare the market for it. Is
Right,
that
exactly. That's the exact lesson there is one of my colleagues, when I was sitting in strategic marketing before managing this project, he said to me, Carsten, that's a really good product for the wrong company. And what we discovered is that we were, in many respects, probably 5 years ahead of our time in terms of what we were showing. So the market wasn't ready for it. So the product hung on till about 93, 94, something like that. And then it was quietly, put to bed because the company didn't have the resources to market it and so on.
Yeah, one of the companies I think that is actually good about that, and that they're from Silicon Valley too, though. I think Apple is actually good at like not being the first. Because
Right,
often the
exactly.
first anything tends to fail,
Yep,
partially because, well, it's the first time they've done it, so there's lots of mistakes and lots of things that aren't quite
right,
the way they should be. But then also the market's just not quite ready for it.
right. If you look at the Vision Pro, that's an example where they did it the opposite. They
Hmm.
got way out ahead of themselves. Technologically, a fantastic project, but it
Yeah.
was too early.
Yeah, like the iPod and the iPhone were both, they were not the first in that category.
No, no. And I mean, the first smartphone was the Nokia, I think it was a 209100. I saw that in Finland in 1988, 87 or thereabouts, or 97. And they just considered it a niche type oddity that there was not a broad market for.
It's interesting though, because there is this idea in Silicon Valley of being the first mover and being the first one to get something up. And I think maybe part of that has to do with the whole like social media type takeover of everything, where like
Right.
it's all about network effects. Because there, when you're talking about network effects, there probably is some advantage to being the first mover.
Yeah, but they come and go also. I mean, remember search engines,
MySpace,
how
yeah.
that was. Alta Vista, remember Alta Vista?
Yeah. Well, to go back to like our AI conversation, I always have this conversation with people. I'm like, oh, AI is the worst that it will ever be, and it will only ever get better. And then I think about Google search, and it has
Right,
not
it's going
only
downhill.
it's gone downhill. So
That's right.
just because it's technology doesn't necessarily mean that it's always going to get better.
But the problem is that the guy who, like Google, who do this, they have a huge conflict of interest, and that's pushing the paid ads up front. I mean, how
Yeah.
ti many times when you do a Google search do you get the organic, correct result?
Yeah. Well, I think part of that is our aversion to paying for certain things. I think Facebook's the same way, right? Facebook started out as this thing that connected people and it was great and everybody loved it. And then it turned into this advertising thing. And, if people had been paying for that from the beginning, would it have went down that same road? Maybe, maybe not. But
Yeah,
there would have been less pressure on Facebook. Because I imagine for all these companies, it's like, well, we've got this service. People don't want to pay for it, but how do we pay for our internal costs, right? And
right.
that advertising is the
And,
natural.
and you have the huge conflict of interest between Europe and with GDPR rules and privacy protection in the US, where it's wide open.
Yeah, if anything, I feel like in the US it's going to be even more wide open. I mean, I don't even
Right.
think that's
And of
possible.
course, the government just loves that because Facebook and those type of things and Google, they're the perfect spy tools for the government to get their nose in there and figure out what they need to know. It's a better
Yeah,
spy network than NSA ever has done.
that is part of it, but the other part of it too, I read a book recently from a lady who worked at Facebook, and basically when they were selling it, they were going around and helping all these presidential campaigns in all these countries because they're like, hey, if we help them get elected, then
Yeah.
they'll look out for us. And so I think that worked because if you want to get elected, you got to get your message out there, and if Facebook is going to help you promote that,
Right. Yep.
then why would you go regulate them? So, and also, I mean, they are. I don't know that the targeted advertising actually has the effect that people think it does, but they are very good at doing targeted advertising.
And
And
that is what they're using all their AI for, is
mhm,
to target even more specifically. I
yeah,
mean, like Zuckerberg, he says, we want to be able to predict what you're going to do the next 5 minutes from now.
yeah. Well, to tie it back to NI, I do remember, and this got a around a standing ovation when he said it, and I think it was Starclough at one of the NI Connects. He said something about you guys are solving real problems. He's like, Google's got all these engineers out there. They hire all these people. They pay them tons of money to make better ads. He's like, but you guys are solving real problems, and I thought that was a very interesting. He's like, what a waste of brain
Right.
power.
And I think that's one of the things that I really think is fantastic about it. And I mean, one of Dr. T's unfulfilled dreams was this graphic system designer. He talked about that endlessly while I was there and also many years thereafter, and always trying to get the organization to figure out what this thing was. And when you look at LabVIEW, it is a graphical system designer. It's a virtual instrument engineering workbench. That's what the acronym stands for. But the 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 product has not been extended enough to do more of those high level type stuff. We use it casually for that. And then with the vertical market focus, and I then thought that this was doing APIs into manufacturing systems and management systems and so on, where it's just integrating the entire engineering workflow that is important.
Yeah, I
And
think. Yeah, NI, I think, has taken a few steps in that direction. Like, for example, like the introduction of channel wires, one of Jeff K's ideas, that kind of like
right,
give try, an attempt to try to give you more of like a bigger system level view. And there's a tool somebody wrote called VIP that lets you like basically zoom in or out. So you're on a block diagram, you see a sub VI, and you just
right,
hover and it opens a panel. And
yep,
then NXG, I think, when it was around, also had something with like hardware and like viewing the connections between different pieces of hardware or something. Do you remember that? I didn't
yeah, I
really.
remember that.
Yeah.
I mean, there are some good things in NXG. There are also some terrible things in there. But the,
Yeah.
the the
Shame
the
that
issue is that the company became rudderless in the last, probably from 2010 and on. The single coherent vision perished, and the company started going all kinds of different directions. And I'm glad to see that, I think partially thanks to the very vocal community with you and many others, that they're getting back on track again.
Yeah, it definitely did feel like there was a lack of vision for a while. And
Yep.
I think that's something that pretty much every company goes through at some point if you become a company because you've got the founders, they've got the vision, they're driving it, and then the founders step down, and particularly if you become a publicly traded company, there's all this pressure. And if there's nobody there to pick up that banner of the vision, it
Right,
becomes this just like, hey, let's make as much money as possible kind of thing, and that
right.
leads you out down the wrong track.
I know at GDevCon in Chicago, I started working on my slides there, and one of the things that I really appreciated about Dr. T is his little isms, Dr. T isms. You've probably seen that on YouTube. We put all 33 of them or 34 of them on YouTube. And these are just 1 minute things. And they embody, in my opinion, extremely deep wisdom that requires a lot of explanation. And just about all of the things that you do in a well-run company is the genius of the end, where you have two opposing forces that are naturally opposing in conventional thinking. You want the product cheaper and faster. Well, that's not the way it works. If you want a faster car, it'll be more expensive. And Dr. T says that innovation comes from combining two things that inherently are thought of as pulling in different directions. And I remember one of the Danish engineers that I brought over from Denmark, who was a good at A to D converters. I was shooting the bull with him in my office, and I was telling him about the genius of the end. And he says, Carsten, you're so full of BS. I'm so tired of hearing all this American nonsense. And I, went on about the genius of the end of doing either cheaper and faster or so on. And he finally stomped out of my office, and he came back 3 weeks later, fuming mad. Damn it, Carsten, I just built this circuit that's half the price and 6 dB better dynamic range.
Yeah, well, I think the it's binary thinking. It's like I have to pick one or the other. And like I think
Right.
lines
The
you
creativity comes in the creativity. Just like humor is a very important creative thing because you're combining elements that don't fit together.
That's an interesting way of looking at it. Yeah, I'd not heard it defined that way, but that is very interesting.
Yeah. And that's why having fun is okay, because when you're having fun, you're relaxed and you're doing all kinds of crazy things that, don't fit together normally. And then suddenly, aha,
Yeah. That's something I've kind of trained myself to do though. Anytime I feel like I only have two choices, it's always worth taking a step back and saying,
right.
is there a third choice or something that where I can get what I want out of both of those two choices without the negative side effects?
That's right. And, those are some very valuable ways of thinking. I think another thing is that, like you said, this business of the project I worked at Brüel Kjær, that it was ahead of its time, it wasn't the right time, and so on. PXI was born at the right time. And I don't know if you read the story about it. In 1997, we're at the Winter Sales Conference down at the Marriott in Austin. And the engineering group has this trade show where they show all their bird's nest and prototypes to the salespeople long before they're released publicly. And we're standing there drinking beers, and I said to some of the guys, I said, hey guys, if we're going to take VXI and a blank slate and redo it, how would we do it today? And Kevin Schultz, he says, well, we'd probably take the compact PCI bus. And Keith Odom said, well, we'd take the plug and play framework. And Ron Wolf said, we'll do this and that and so on. So we quickly brainstormed on that. And 15 minutes later, I said, well, that sounds like the right idea. Let's call it PXI. And they said, PXI. Anyway, Dr. T walked by, and Ron Wolf gave him the 30-second elevator pitch about this new platform. And Dr. T, he just almost didn't stop walking. He says, sounds good to me. And Ron Wolf said, we'll have it on the covers of 25 trade magazines in August, 8 months from now. Kevin Schultz said we'll have at least 10 hardware products shipping by NI week and so on. And the rest is history, it's $1 billion market today. And there was really no genius in that. I was just seeing that all the stars and planets were all lined up and the time was right to make that step.
Yeah, well, it's also too, I think it says something about Dr. T. You mentioned earlier, trusting people,
Yep.
right? Because I could easily see, oh, that's a great idea. Let's have a committee to look at it and let's make sure we got all our ducks in a row. And as opposed to like, hey, this is your idea, go run with it. And
Right. We had 30 engineers redeployed Monday morning to work on it. The time schedule was NI week.
yeah,
There was no budget because the time constraint determines the budget. And you know what the biggest challenge was? Engineering thought it was such a boring project because it was just taking existing PCI boards and packaging them on compact PXI or P, yeah. So we had to recruit the salespeople to walk around in engineering and telling them that this was the greatest thing since sliced bread and get them motivated.
that's funny.
But
Yeah,
there's another interesting thing in that, which again is these opposing forces. Ed Lowenstein was working on the RF stuff very early at that time before, and I had bought some of the old Agilent guys and so on, or Keysight as they became. And I was talking with them about PXI, whether it should be the 3U or the 6U form factor. And Ed Lowenstein says, you can't get anything meaningful in a 3U form factor. It just isn't possible. And I said, good, that settles it. We're
That
going
sounds like a challenge. Yeah.
right,
Well,
because
also,
it goes two ways, because Hewlett Packard, as they were called back then, they would say exactly the same thing. You can't get anything meaningful in it. And I was thinking back about the Cray supercomputers, which were built in a circular fashion to keep the lead length short. And in a small chassis, you have shorter propagation times on the backplane and so on, faster triggering and more precise timing. And that's what I was thinking about 10 years down the road. And as technology emerged, they were able to cram the RF and microwave into PXI. And if it had been done in the 6U form factor, it would have been that's just the same as VME and VXI. There's nothing new and sexy about it. But the factor came in that the footprint was dramatically decreased.
yeah, when you said that, oh, you can't cram anything useful into 3U, my immediate thought was, but if you could, you would be the only, right? Like,
Right, but that was a 10-year perspective.
opportunity in that.
And it took HP 12 years to sign on to the bus.
Yeah.
We were a group that flew up to Loveland 3 weeks before it was announced, and we had the slot zero controller along, and we invited them to join an open consortium to standardize this.
Yeah.
And it was supposed to be a friendly meeting, and after they saw the products and they were passed around, they just sat there, shook their head, and the meeting was terminated early, and we were shown the front door. They didn't want to play.
Yeah. I don't know. Maybe I'm just a contrarian, but every time somebody says, oh, you can't do that, I'm like, but my first reaction is always like, well, why? Why can't you do that? Like,
Exactly. Well,
yeah.
I mean, engineers love challenges, and they're proud as popes when they
Yeah.
succeed.
Yeah, a friend of mine called it nerd sniping. You find somebody who's really nerdy and you just give them a challenge that you once solved and just throwing the challenge down.
Yeah, yeah,
They come back like a week later with the answer. And you're like, oh, okay.
right. And the thing is, me not having a formal engineering education, I wasn't constrained about what was possible or not.
Ah,
And I remember back at Brüel Kjær, we had a sound analyzer that had a dynamic range of 60 decibels. And I said, well, the typical microphone transducers that we have in the company, they're 120 dB dynamic range. So I said, why don't you build a box with a 120 dB dynamic range A to D converter? And they started laughing at me and saying, yeah, it's good you don't work in engineering, you're crazy. You just stay with the strategic marketing. And they went and built it.
that's funny.
It's the
Yeah,
same thing. I don't know if you remember the Flex A to D converter that NI had.
yeah.
It was
Uh,
a trade-off of 24 bits at the lower frequencies and 16, 18 bits at the
ah,
megahertz range. And one of the Danish engineers who I brought over for interviews, Dr. T, I'd been trying to sell him on these guys. I said, they're really good. So he called them in he wanted to talk with them. And this was back in 94, 95. He says, can you build a 1 megahertz 18-bit ADD converter? And obviously the answer is no. But he threw it out at them. And then they sat there, yeah. Yeah, they sort of, nah, that's probably too difficult. We think that's beyond state of the art. So they went back to the hotel, had a couple of beers. They called me in the morning. Can we talk with them again?
we
So
figured
they
it out.
had a talk with them in the morning there. Well, now they had the idea how to do it. And that product had nine US patents and was the product of the year when it was announced in the electronics magazines.
So much is about your mindset of what's possible. There's a story, the first guy to run like the 4 minute mile or something, right? For like years,
Right.
everybody said, oh, you can't run a 4 minute mile. Oh my God, it's crazy. And this one guy, and I forget the exact name of the guy, I should know this, but he's just like, yeah, I'm going to do it. And he did it. And within like a year, like several other people had already done it.
Right.
And so it's just like, oh, wow. Yeah.
Right. I think another thing I really liked about Dr. T is every employee, at least in engineering, should spend 10% of his time every day thinking about things beyond what he's currently working on, irrespective of how busy you are. So you're constantly dreaming about the roadmap for 5 or 10 years from now.
Yeah. Along those lines, I am very much a believer in the idea of the Renaissance man. If you look back at like history, like in the 1600s or whatever, like all of those great thinkers, they were never
Yep,
in just one discipline. They were always in multiple disciplines. And I
right,
think there's a lot of value in bringing outside perspectives in. To
right.
your point about like, well, I didn't know you couldn't, so I did, right? Like if you don't know what the rules are, it's very easy to challenge the rules and challenge the normalized thinking. And you avoid that groupthink problem.
Right. I mean, if you look at Steve Jobs, he wasn't an engineer educated type person, and that permitted him to not be constrained by what was possible. And he going in and says, I want beautiful fonts on the Mac because he'd gone to a calligraphy course. And they said, well, that's not possible. And he said, do it. And they did.
Yeah, sometimes you just need that prod and
Yep.
that idea that, well, it should be possible, so let's go do it. Yeah. It's been a very good conversation. Is there any closing thoughts that you have? Any last minute things that you want to talk about?
Well, I mean, there's a lot of other things that we'll be talking about at GDevCon in Chicago about how to manage big projects, how to motivate people, how not to motivate people, and so on. And it's a fascinating thing. And I'm also going to be talking about that every individual engineering group has a operating system that they run by. They don't think of it as an operating system. And every individual person has their own POS, personal operating system. Some managers are schedule, round robin scheduling, some are interrupt driven. There are many different ways of running your own life. And I think these, how they play together and respecting people's skill sets there and fitting them into the organization and how you run things is a very, very important skill. And Dr. T had a really good sixth sense in terms of which engineering teams worked well in one way or another, which ones required tighter controls, and which ones you could sort of run with a very loose leash on them. And that art of management is a real art.
Yeah,
You don't
you hit
want
on
working on the stuff they have to work on all the time.
yeah, well, you hit on something there. I think you said how to motivate people, how to not motivate people. And I think sometimes part of we feel like we need to learn new things and develop new skills and we need to build and that's important, but sometimes what's more important is what you don't do. So
Yeah,
like there are certain things that just like kill team motivation and things and like not doing those things is almost as important as learning to do this new thing. So
right.
that's an
And,
interesting
and
one.
also getting people on the right job. We had an issue when I was there. One engineer who had, in my opinion, mismanaged a project that he was working on, and it went off the rails, and it never ended up shipping like it should have been. And we had discussions, should this guy continue his work at NI? And Dr. Z said, you know, I think he'd be very good if we moved him over into another group. That would be a good fit for his skills. Why I was sort of going in the direction that maybe we should ask him to find another job. And I think this business of understanding to get the right people on the right chair in the right position so that you exploit their talents, because some people are very good at one thing but not in another. And he was very good at seeing that.
Yeah, I mean, to that I would go like there was some reason that you hired them, and maybe that's not the best fit where they are now. But
Right,
also, yeah, it's cheaper to keep that person around and move them somewhere else if they're going to be a good fit than it is to go hire somebody new
right.
anyway. So, yeah.
There are, of course, also employees who are high maintenance employees. I always have a rule of thumb, do they contribute energy to the system or do they suck energy out of the system? And that is a hire fire criteria that's quite simple.
Yeah, definitely. I do think there is a reluctance in some large corporations to move people along, whether it's firing them or moving them to another job. They tend to just kind of sit there. And yeah.
All right.
All right. Well, thank you very much. It was a good conversation. And if people want to learn more, they can come to GDevCon NA.
Yeah.
listen to the keynote, and I'm
I look
I'm
forward to
sure if
that.
they buy you a beer, you will tell them whatever they want to hear, right?
Yeah, right. Yeah, we'll work for we'll work for beer and pizza.
Yeah. We used to have with like beer and T-shirts or something. Yeah, because we would always we'd volunteer to teach this rock climbing school, and they'd always give us T-shirts at the end of the year and buy us beer. So,
Right. How many people do you expect to be at GDevCon?
I think we're aiming for like 150 to 180, somewhere in that range.
Okay. Yeah. Yeah.
Yeah. So,
All right.
very good. Thank you.
Okay. Good to see you, Tim.
All right. Cool.
Always appreciate your fantastic input to the community.
Yeah, I enjoy. Oh, we didn't even really mention, but you have the History of NI website, right? Is that? Well,
Yeah,
what,
that's right. Yeah. Yeah.
historyofni.com? Is that it?
nihistory.com
Okay,
and
cool.
also nihistory.org. And the biggest problem is I have a lot of other irons in the fire, so I don't always update it as frequently as I'd like to.
Okay.
But we talked about putting it on Facebook, but then it becomes, it loses its structure, it loses its permanent because Facebook is always jerking you around, wanting you to look at the things they want you to look at and distracting you with things. But
Yeah, that is one piece of advice actually I would give to anybody listening. If you want to start your own blog or something, don't do it on a social media platform. Do
no,
something
that's right.
yeah.
Because, and that's why we went and bought the domain, and we have our own hosting on it, on paid hosting. And because as a history blog, I want the stuff on there to not go away.
Yeah. No, definitely that is very much worth thinking about.
Right.
All right. Well, thank you.
Okay, thank you much.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.